Hallo allemaal, ik ben Mike Lehan, and that's the only Dutch I'm going to speak for the rest of this talk. I'm CTO at a UK-based prop tech company called Students. You can follow me on social media at m1kphpc.social on the Fediverse, or feel free to add me on LinkedIn. And today I'm talking about the topic of hacking yourself. And we might begin with a question as to why you want to hack yourself. This seems like a pretty unproductive thing to want to do. Penetration testing, by virtue of its quite niche nature, is a specialist topic. It requires a lot of training, it requires a lot of specialist knowledge and continual learning and development. And if you hire penetration testers to break your application, you may find that they discover issues with it. But you may also find you spend a lot of money acquiring that information. And in fact, a lot of the things penetration testers will do will begin with automated scans, scanning your application using tools. And so I think it's important that we learn what those tools are. As people in our software engineering teams, as people in DevOps teams, knowing those tools, knowing how to use them, can save us time, save us money on testing, so that when we bring in professionals to hack our systems, they're not finding really easy bugs that we could have already have identified. So this is a talk introducing an open source penetration testing tool called ZAP to a developer community, thinking that we want to move security into the developer and DevOps worlds rather than just leaving it to security people. There's already been a talk this morning talking about the concepts of shifting left, and this is part of that process. And so why use ZAP? Well, ZAP is open source, and that's a big advantage because it means it's free to use. It also has spawned loads and loads of different plugins, and it's got lots of different features that wouldn't necessarily exist in a closed source system that was also being offered for free. It was initially supported by OWASP, the Open Web Application Security Project, and as of last year has moved to the Linux Foundation, which is really great news because the Linux Foundation are paying for, at the moment, 2 full-time engineers to work on ZAP and increase its features. So even though it's an open source system, it's also got professional people being paid to spend their time working on it at the moment. And ZAP stands for Z-Attack Proxy, and we'll get into the proxy a bit later. Now, the rest of this talk is going to be a live demo. We're going to demonstrate ZAP's tools. So put your hands up if you'd like me to hack your website. Oh, no takers? Oh, there's a few takers. Some very brave people. No, we're not going to hack someone's website. For the start, it might not work, and then I'd look bad. Or it might work, and you'd look bad, and I might get arrested on my way out of the country tomorrow. So we're not going to hack anyone's actual website. We're going to use a test system. And this is another OWASP project. If you may have come across it. If not, definitely check it out. This is the Juice Shop. The Juice Shop bills itself as the world's best insecure web application. It is mimicking a real web application. It has a store, you can log in, create accounts, you can add things to a basket, you can buy things, but it's also completely insecure by design. It has a bunch of faults that are deliberately there so that you can learn how to identify those faults in your own applications and even fix them. And the OWASP Juice Shop, again, it's OWASP, it's not related to ZAP, but it is a really good test case for using ZAP. So, we're going to hack the OWASP Juice Shop in this rest of this session. One thing that's worth mentioning is that the Juice Shop, being a testing tool and a training tool, will tell you when you've hacked it, which is really useful when you're trying to hack it. Most real-world websites don't do this. They don't tell you, hey, you just hacked me, good job. So you'll see a few things that happen in the Juice Shop hack that you think, oh, what did they do to achieve this? Sometimes the Juice Shop is just doing it for us by telling us, hey, you've hacked me. So just be aware of that as we go through. And now for the live demo. So the first thing I want to show you is the Juice Shop itself, just so that we know what our target is and what we're doing. I've set up the Juice Shop. It's running in a Docker container on my machine. And we have things like our account. I've already created a user account and logged into it. We can do things that you could do with any other web shop. We can leave reviews for products. Submit that. We can add a product to our basket. And we can see that. And then there's various other features like sending feedback or complaints that you can use. It's hopefully a relatively familiar application. And now to introduce ZAP. And hopefully it's pretty visible on this screen. Excellent. When I was initially preparing this talk, I was working in ZAP's default layout and style, which is all white. And then someone told me, by the way, your talk's going to be projected on a massive cinema screen. Please put your slides in dark mode. And luckily, just a few months ago, ZAP released dark mode. So you have the ZAP developers and the Linux Foundation to thank for the fact that your eyes aren't all being burned right now. We're going to begin with an automated scan. We're going to point ZAP at our test website running on my machine. Before we do this, a word of warning. You see this button here? Hopefully you can see it. Yes. I'm going to sometimes be looking at my screen. Sometimes you try and point up there. I'll try and remember to do the two. This button says attack. This is a first indication of you that you should not click this button if the URL that you've put into the box above is not a website you have permission to launch an attack on. So even though this is a tool that you want to learn and develop and research, do not point ZAP at a website that A, you don't have permission to penetration test, or B, that you'd be unhappy if it actually got hacked. So for example, you might have permission to penetrate your company's production service, but you should maybe be careful running ZAP on the production website. It might do things that you don't want to do. Even if it doesn't hack it, it can sometimes add a lot of fake data or other things that you wouldn't want to happen. The best place to test ZAP to start with is on a local version of your system, potentially on staging if you don't have a staging environment with production data on it. But do remember, in the real world, the baddies are hacking your production system. So you'll want to ramp up eventually to have the trust in your application that you can point ZAP at it and not worry about the results. So we're going to put in our local host and running on port 3000, which has become customary for everything these days. And we're going to hit the attack button. Straight away, ZAP gets to work. The first thing it's doing, we can see from here, is the spider. So we spider the website. The spider is not a specifically hacking tool. The spider is similar to something like Google or Bingbot, which is going to explore your website to see what it can find. It's not doing anything weird or malicious. It's going on your homepage, localhost 3000 in this case, and then it's going to go down and find every link in the homepage and follow that link, and then find those pages and follow the links from those pages. The spider is smart enough not to go back on itself and get an infinite loop. And it will also, you can set a default depth. The default depth is set to 6 links. I've left it on there. If you have a particularly complicated website with just huge numbers of different routes and different routing patterns, you might want to increase that so it actually finds everything. But the spider isn't doing anything malicious. It's just exploring. The one thing it could do that an average user won't do is it might find links in comments, because it will just scan for anything that looks like a link in your code base that it can access. But it's not doing any actual hacking. The actual hacking comes from this, the active scan that's now running. The active scan is running a set of plugins. Most of these are plugins that come with ZAP, but you can install other plugins yourself. I'm actually going to skip this one because it takes ages and I know it doesn't do anything for the juice shop. And the active scan is actually hacking your website. It's sending requests from different plugins known to have payloads that can trigger common vulnerabilities, such as SQL injection. Or maybe unpopular bugs, such as the log4shell vulnerability, or other common misconfigurations of web services. And the cool thing about plugins is you can write your own. And again, this whole thing's open source. You can write your own plugins for it. And so if you did have a security breach and your engineers rectified a security problem in your application, you could potentially write a plugin to check for that problem in future, so it doesn't reoccur in the future. So ZAP almost becomes part of your regression testing, and you can even build it into your CI processes. And so it's running this scan, and as it's running this scan on our website, we can look at, if I close that, alerts that it generates. So it's telling us if it's finding things. So we see the findings. I'll just move out of the way here so you can see them. We see the findings over here with these wonderfully pixelated icons because of how big I've had to blow it up for the screen. And we can see at the top there is a more serious finding. The cloud metadata is potentially exposed. This finding is actually a false finding. This is if you click this, double-click this, it will actually give you, in a very small window there, but very big on the screen, hopefully, it will give you an explanation of what this issue is. So the plugin that's finding this issue tells us that this is part of the OWASP top 10. So it's one of the top 10 vulnerabilities they find in websites. And it's related to cloud service configurations. AWS, Google Cloud, Azure all have this concept of server metadata. And this thinks it's found server metadata. In this specific case for the juice shop, it's not found anything actually dangerous. It has just requested latest metadata, which is a common path that's used. And the juice shop has this slightly weird quirk that it responds to incorrect URLs with a 200 response, which is a bit silly, but it does that anyway. But this is a false positive, and we can actually mark it as that so we don't get distracted by it later on in our testing. And from this point on, we can start to explore some of the other issues here. But at this stage, it's not particularly interesting. We found some stuff, but we don't know what it's actually doing. Let's check our application. So back on our application, we can actually see that the juice shop has popped up 2 messages telling us that we've found some of the secrets it holds. Again, most websites will not pop up a little green banner, and it actually does confetti as well, when you hack them. But the juice shop does. And also, it'll do another one when I shift close these notifications. The juice shop also has something most websites don't have, which is a scoreboard telling you how much of the website you've hacked so far. Again, this is not normal. If your website has one of these, I would love to know the use case for it. But this is very useful for if we're trying to learn how to use ZAP, and we can see some of the issues that we've already exposed without us even realizing it when we ran our initial scan. We exposed a confidential document and provoked some bad error handling. And if we look in our spider and just sort by URI here, and scroll down, scroll up even, we can see that our spider identified this URL. I'll try and point to it. ftp/acquisitions.md, which sounds a little bit interesting, and we can open that in our browser. So ftp/acquisitions.md, and it loads a document, which is confidential, do not distribute. A company plans to acquire several competitors. So we've just found something without even doing much actual hacking, just running ZAP on a system. We found a document that someone buried in an FTP directory, and ZAP discovered it and has told you about it. And again, the juice shop told us as well. We talked about ZAP being a proxy, and this is where ZAP gets really interesting. So we've done a scan, an automated scan, and we found a few things, but it's nothing particularly juicy or dangerous just yet. We can also manually explore a website, and this is good because it combines the ability of an automated testing tool with your own knowledge as a developer of the website, especially if this is your website that you use. You might know stuff about it that even a penetration tester wouldn't know, and you can use that knowledge to see, well, even if I had full knowledge, so maybe a malicious insider, someone who used to work for you, someone who downloads your source code, could they actually hack us? And we can launch a browser to demonstrate this tool. So we open a Firefox browser. You'll notice straight away that the Firefox browser here is running a bit differently from the one I had open a moment ago. The top bar right up there is very obviously red, and there's a little angry-looking robot figure at the side of the URL. And that's because Firefox is very keen to let you know that it's currently being remote controlled, so you don't start doing other stuff in it, like log into your online banking, and suddenly you find out that that's appeared in the logs for the ZAP tool that your team is running. So Firefox tells you that. And the other thing you'll notice is an enormous and rather scary-looking airline pilot's face has appeared right in the middle of the screen for the ZAP heads-up display. If you are using ZAP for the first time and you want to do the heads-up display, I would urge you to click this button, take the HUD tutorial. It takes about half an hour. I did think of just running through that with you, and that would be my talk done and dusted. But I felt that that would be, you've not come all this way to just do something you could have done at home. I very much recommend you go and do that. I'm going to hit continue to your target. I'm going to dismiss the standard cookie notices that everything does these days. And you'll see that we have the heads-up display displayed on the screen. You've got these buttons on this side, some on that side, and a little bar at the bottom giving a history of some of your requests that you've made. If you're ever using the HUD and it gets in your way, you can press this little button down here, at the bottom over there, to hide it. And the first thing you want to do when using the HUD is set your website as in scope. In scope is a very useful concept because it stops ZAP from attacking websites that you don't have permission to test. For example, if you have your website you're testing, but it links to the website of your group that your company's in, or GitHub, or Amazon Web Services, or somewhere else, you don't want to accidentally stray onto there and ZAP's just in the background sending random SQL injection requests and trying to hack them as well. You might get in trouble. So we hit Add to Scope. We add our current domain to the scope. We're also going to log in because we do have access to log in. This is a shop. You can create user accounts, so it's not particularly malicious to log in with an account. I created an account earlier just to add some fake data to it. So test@email.com with the super secure password ABC123. Hit remember me and log in. So we're now logged in. You'll see straight away down the bottom there, they'll disappear in a second, that ZAP has spotted a few things, just information. This isn't giving us anything really gnarly. It's just telling us how this website's working. It spotted that we did a login. Maybe that's the word login in the URL. Maybe it's the fact that it was a JSON body containing email and password fields, but it identified we did a login. This is very useful when you're doing reconnaissance on a website to find out how does a user log into it. And maybe sometimes they'll log in a way that you didn't expect. You just fill in a form and suddenly you've been logged in and you're like, hang on, that's not normal. And it's also showed you a session management response. So you know that these URLs are using some sort of session. In this case, it's a JSON web token. So again, you can look at that in the history and explore it to find out what you can do with that data. And now we're in here, we're going to run another test. The advantage of running a test in the browser is that with a lot of web applications today, you won't have a sort of HTML structure that has all your links and all your forms that does everything for you. You're probably using some sort of front-end JavaScript package, a framework, or just your own custom JavaScript. And through that, you are rendering things into the page that don't exist if you just look at the raw source code. So running a scan inside the browser takes advantage of the fact that the browser has rendered our whole page. And I'm going to run a scan on localhost here. And so straight away, we've just solved a challenge. Again, confetti, not happening on a real website, sadly. But we've viewed another user shopping basket. How? I don't know. ZAP has just found this. What it did was it queried the website, and it queried all the different URLs on the website, and it saw the link to our shopping basket. And it decided, hang on, there's a link to shopping basket that ends with ID 6. What if I put ID 1 into that? And you found another user shopping basket, because for some unknown reason, the developer of this website made shopping baskets accessible via an easily iterable ID, which you really shouldn't do. But obviously, they knew that because they were a testing company. We're going to close that and let this run. And once again, I'm going to just jump on here quickly and skip this cross-site scripting one. The reason the cross-site scripting one takes ages is because doing different injections to try and see if you can pop JavaScript on a website is quite complicated. But the GShop does have those vulnerabilities, but I know that ZAP doesn't find them. And we're going to do a few things like that throughout this talk, where I'm going to kind of skip over something where in reality you would have had to leave ZAP running for an hour or so maybe to find something. But I didn't think you'd all just want to sit here and watch a progress bar move. That's not the most engaging talk. As we do this scan, I'm going to close this again, we've seen a new alert come up. I'm going to run over to it here. SQL injection. Hands up if you know what SQL injection is. Excellent, well-trained group of engineers in this room. So I don't need to explain the basics of SQL injection. Here's how ZAP knows it found SQL injection. It sent this string here at the top there. 2728 URL encoded is an apostrophe and then a closing bracket. And it received this very informative SQLite error. This developer has done two things wrong. Firstly, exposing error messages on the public API. You definitely shouldn't do this, but in this case, they've actually done something rather helpful, which is they've identified that there's a SQLite vulnerability here. If they hadn't exposed the error messages, we wouldn't have spotted this in the automated scan, but we might still have had the vulnerability. We just wouldn't know about it. So maybe it is helpful after all. Expose your error messages. Go on, I dare you. And we can see that it's running a query. If I just set this into word wrap mode, we can see it's running this query. Select all from products where name is like a bunch of stuff, and that's our bracket. Sorry, it wasn't a closed bracket, it's an open bracket. And we can work out where our injection point is by changing this. So we can hit Control-W, which moves us into the requester. And I'm going to replace that that open bracket, because it's not useful. I'm going to put a word in that we can easily spot in the query. So I'm going to put the word chicken in and hit enter. And there we go. Select from products where name like chicken or description like chicken. So there's our injection points, this apostrophe and this word chicken here. And from this point, we can start to craft something like our own version of the query. We know that we can inject into this field here and this field here. And that means we can say where name is like something, and we can maybe close that bracket earlier after the percentage sign. So we're going to put in two closing brackets. And then we're going to comment out the rest of the query. So SQLite just runs our first bit. And we hit enter now, and we get our SQL injection vulnerability, where we're now returning all the products in the store. But that's kind of useful. We could pass through that. But there's also some interesting stuff we could do if we want to. Let's just break this again so we can see the query. We can see the query is selecting select products. And at the end here, it says where deleted at is null. This is quite common in databases. You might not actually delete something. You might just hide it. What happens when deleted at is not null? Let's find out. So we're going to change our query here, and we're going to craft it to say select where name is like nothing and deleted at is null. And then there we go, and limit 1. Oh, sorry, is not null. Yeah, my bad. This is why you have an audience for these things. There we go. We found the 2014 Christmas Super Surprise Box. That's interesting. It was deleted. Can we order one? Well, we can look at the proxy. We can add something to our basket. Back on this page, add to our basket, add some tasty apple juice to our basket, and go to our history. The history here is everything we do, and it's off the bottom of the projector here, which is wonderful. So I'm just going to make another request to add something else to our basket. So now it's not off the bottom of the projector. So we can see we have a post request here to basket items. If we double click on that, we can see the item. So we added product ID 1 to basket ID 6. So straight away I can see you could probably add it to someone else's basket as well, which could be fun, just to confuse someone. But can we add our deleted product? So we change that in the requester, we hit Alt-Enter to run it, and we got a success response, and we go into our basket, and we can see the Christmas Super Surprise Box 2014 edition, and it's been deleted so thoroughly that it doesn't even have an image anymore, but not as full enough for us. We can check this out, select our address, which was added before, and this, and a card, this is why I added these earlier, and pay, and the Juice Shop tells us we've solved that challenge. Now, ordering the Christmas surprise box maybe just confuses some poor factory worker who spends ages looking for it. What else can we do now we have access to this database? Well, what if we try and access a different table? Hands up if you've heard of a union query in SQL. Excellent. The union query in SQL is great because we realized early on that we only control one part of this query. If I just break it again, we control the part from here onwards. We don't control this bit, so sadly we can't just say select all users because we start with select all from products. But we can run a select from products with a union to select from a different table as well. The challenge you have when running unions is that your set of columns in your first query and any subsequent queries you union must match. And so because we've got this select all, the next bit is quite laboriously intensive, trying to figure out what columns we need to return from our users table. You can do this, however, but so that you don't have to watch it, I've made one earlier. So I select this previously made query, paste it into my top line, hit enter, and we have the users table dumped here. We will notice that there's a select here, and it's selecting email and password, which are going into the first two fields, which in the products table were ID and name. So where it says ID, that's actually the user's email, and name is their hashed password. So we even have the admin's details here. So the admin at Juice Shop and their hashed password. Now, this doesn't look like a necessarily secure hash. It's definitely not a modern PHP password encryption item, so maybe it's a SHA hash, looking at the length of it. But we could probably have a go at cracking that, or something else, but we've just breached the users table. And in SQLite especially, but in most databases, there is a way through the database to find out about the database, which lets you do all sorts of fun injection attacks for the rest of it. In SQLite, this table is called SQLite master. And so if I copy this here, in MySQL, this would be the information schema table, we now have a list of everything in the database. We now know all the tables and all the fields, and we can craft SQL injections to our heart's content. And if we go back on the Juice Shop page, you see that we've cracked a few of the challenges that the Juice Shop has been watching us for as well. So that's some SQL injection, and you can have quite a lot of fun with that, crafting different exploits. So injection is pretty cool, but something else that's cool, if you don't have a way to inject, which it should be secure in most websites these days that you shouldn't inject if you're passing raw strings into your SQL queries, please stop doing that and use something like PDO. But we can hack this website in other ways. Earlier we logged in. Let's try and log out. We found the admin's email address, didn't we? We found admin at Juice Shop a few queries ago. Let's just go back so I can copy it correctly because it's slightly weirdly formatted. This one. Yeah, admin Juice Shop. So let's copy that and we'll log out as our user, and we'll try and log in as this admin. And let's just try a really obvious password like admin. Admin. Log in. Doesn't work. Okay. Let's try password. Okay. Maybe this admin's old school. Password. Log in. Doesn't work as well. We can see these requests down here. So we've got the login here for admin at Juice Shop, password admin. People use common passwords all the time, and passwords appear in breaches all the time. Wouldn't it be great if we could try all of those different passwords? Well, we can, using another tool from ZAP called the fuzzer. We can open up a fuzz dialog, and we can select this password here. So we select our password. This is our fuzz location. Hopefully everyone can see that. And we're going to add a fuzz location to this. So we're going to add and I'm going to select some file fuzzers. Now, ZAP comes with a set of default file fuzzers. This one, Deerbuster, and this one, JBroFuzz. But he got bullied at school. But I've also added a FuzzDB, which is a plugin, which just contains a huge number of different strings that do different fun things with websites. And we could run some of these against this password. In this case, however, once again, we don't have a huge amount of time, so I have compiled a list of 30 basic passwords, which we're going to run to demonstrate the fuzzer, but without you having to all sit here watching a progress bar again. And I happen to know the admin's password is in this, so a few steps have been skipped in this process. I add this, and I add this fuzzing location. So now we see the green is fuzzing this green here, and we start the fuzzer, and we see that for all of our requests, if I scroll up here, we get a 401 unauthorized, which is for a forbidden unauthorized response for the wrong password. But if we sort this, you see that in one specific case, we get a 200 OK with the password admin123. Oh, we nearly had it with admin, but admin123. We should have guessed that, shouldn't we, really? And in this case, we've got an authentication token back for the admin. We could now use their password to go and log in. Or, given we've just logged in as them anyway, we could use this token to send further JSON Web Token requests as the admin user. And once again, if we go back on the Juice Shop, we've been told, hey, you got the admin's password. And fuzzing can do some other cool things as well. If I log back in as our test user, whose password is the very secure ABC123, we can see that you can add reviews. So I can add a review, test, and I can like my review. And once I've liked my review, this button sort of grays out and I can't click it again. And if I go into my history, maybe there's an easier way we can get past this. We can go to our post request here, which posted the ID of the review to this endpoint, REST product reviews, and it liked the review for us. Let's just send that request again, see if we can get multiple likes and put our review at the top of the list. We're not allowed. The website has thought about this. They've thought that the user liking their own review multiple times would probably be a problem for the service, and they've said you can't do it. Once you've liked your review, that's it, you're done. But how are they checking for that? Are they checking in a way that is compliant towards things like sending multiple requests in the same second, or in the same few milliseconds? Well, we can explore this with the fuzzer. I can make another review, test again. I can go into my list of reviews here, I get request here, and find the ID of my test again review. So there's the ID, and copy that. I can also find my previous attempt to like a review, and I can fuzz it. I'm just going to expand that so you can see it. I'm going to edit the request to put in the new ID. I can't send this request yet as a test, because if I send it, I've probably already tripped the thing that will stop me sending another like. So I have to not send it just yet and trust that I've put the right ID in there. And in this case, we're just going to fuzz a blank part of the file. I'm going to add an empty string, and then I'm going to add another empty string. Then I'm going to add another empty string, and finally another empty string. And that means that this will send 4 requests at the same time. You can change how many threads ZAP will run in parallel. By default, it's 16. I found that running it on my laptop while screen sharing, 16 threads tended to crash the system. So I dropped it down to 7. But if you're running on some sort of beefy hardware, you could send even more requests at one time. But 4 is enough for this test. We're going to start the fuzzer, which will run very quickly because it only runs 4 requests. We can see our demonstration was a 403 forbidden, that we were not allowed to like our review multiple times, but the fuzzer has returned 4 200 OK responses. If we now refresh the page, we can see that our review here, it's very tiny there, but our review has 4 likes. So we have just liked our review 4 times. We could like that a lot of times. We could boost it to the top. We could put a load of fake reviews in and get them to the top of the list and mask all the bad reviews on our product on this store. One final thing I want to show you the fuzzer is exploiting form posts. Like a lot of websites post sort of GDPR, there is a form on here to erase your data. So you can put in your email address, email.com, A, wasn't it? Delete my user data, and I get a message. If I look on the history of my requests, I can open my data erasure post request, and I can spot something that's a bit different from the rest of the website. Most of this website's been working like an API. It's been sending JSON payloads, and it's been receiving JSON payloads that it renders into the system. This data erasure system seems like it's been tacked on as an afterthought. The URL's different, and it's sending a URL, a form URL encoded request instead of a JSON payload, and it's receiving HTML, which it's rendering straight into the page. This offers something interesting for us to explore. Often in forms in websites, that there are parameters that maybe exist in the server knows about or is looking for, that aren't visible to you as the user. You don't know that the server is accepting them. Maybe they were left in from debugging, maybe they were some previous work that was done and the feature was changed. But often you can find interesting exploits if you explore what form parameters can be submitted. We're going to fuzz this request again. And this time, rather than fuzzing the value like we did with the password, we're going to fuzz the form parameter itself. So we're going to say and test equals, let's say, DPC24. Save that, and select our field rather than our value. And we're going to apply some of the fuzzers from the FuzzDB, which is this plugin which has tons of different common fuzzers. Again, I could run the whole fuzzer on it. We'd be here a while, but it would eventually find an exploit. Because I have prepared this in advance, I know that the exploit is in this specific file, and we're just going to run one on it so it doesn't take too long. I'm going to add this as a fuzzer, hit OK, and start fuzzing. This takes slightly longer than some of the other fuzzing we did. And what we're looking for here is something out of the ordinary. It's running all these requests and it's getting 200s. Now, straight away, it's spotted one thing, which is ZAP is telling us, which is reflected. What reflected means is it's seen something that we've sent in our payload come back in the response, which is kind of cool if you put something really intricate and weird in and the website sends it back to you. That could be potentially a cross-site scripting attack that you could exploit. In this case, it's the number 1, which is not particularly informational. Lots of forms will return the number 1 at some point in the response. But if we sort by here we go, sort by code. We see that at one point here, the 1000th fuzzer, that wasn't intentional, it just happened to be the 1000th or 1001th fuzzer, we provoked an internal server error. Generally, it shouldn't be possible for you to provoke a 500 response in a web service. If you change your input, the only thing you should get is a 4x response, because that says that you've done something wrong. You shouldn't have a request that works with one input and doesn't work with another input, and suddenly it's a 5x response. That suggests the server's gone wrong. So it's always something to watch out for. If you're scanning a website and you see a 5x error, that tends to mean something's misconfigured, something's wrong, and you might be able to exploit that. In this case, we sent the parameter layout, and we provoked a 500 internal server error. And we can look at this title of this document, which helpfully it sent us back a HTML document explaining the issue. It's got enoent, which is a code that Node.js uses for when it can't find a file. No such file directory opening juice shop views dpc24.hbs. And know what HBS is the file extension for? It's a handlebars template. So we know it's using Node, it's got enoent there, and it's handlebars templates. So we seem to have stumbled upon a key, which gives us a template. And we can prove this by changing this. So dpc24, hoping they invite me back, dpc25. And we can see that this changes here. dpc25.hbs. We could explore different views. Maybe we'd find a different page, but the views directory of a website often isn't going to be that exciting. You might find something else, like a form, which tells you about a URL you didn't know about, but it's not particularly fascinating. What is really fascinating is directory traversal, which you can do on most systems with a ... and a slash. And if we wanted to examine something like, this is a Node application, so their package.json file. And we hit enter, and we get a package.json file. It's all a test because it's not really there. But we get that package.json file. What can we do with that? Well, we can now do more exploits because we can look at all the dependencies of that application. Are there any CVEs or common vulnerabilities in those packages? Or we can even go further up the tree, .. / etc. password. Anyone? And we can explore the file system of this application. And we discovered that through some fuzzing, through a bit of knowledge of how websites tend to work. So as you can see, ZAP isn't always a sort of silver bullet tool. It's not this magic thing that you point at a website and it just gives you everything. But it gives you a lot of information to work with the things you already know. And I think this is actually a case where engineers, rather than maybe security professionals, are really well equipped. We would know things like what a handlebars template was. We would know things like how our applications tend to be configured, which security teams might not know. I'm not dissing security teams, but we have knowledge that means we should be part of that security process as engineers building these systems. That's my TED talk over. And so what we're going to look at next is a combination of what we saw at the start with the spider and this fuzzer. You might have thought about this fuzzer as, well, what if we just fuzz the URL? And you can definitely fuzz the URL. I thoroughly recommend it. But a combination of the spider and fuzzer is quite interesting, and this is called forced browsing. So I'm going to open up a forced browse window. And the reason we want to force browse is because our spider discovers links that are visible. Our fuzzer can fuzz a specific thing that we've thought about and we've targeted. Force browse combines these two by taking a list of common paths, so things like, think WP-admin, one of the most common paths probably in the PHP world, and things like package.json, and will try all of them. But not only will it try all of them, it will also find anything that it discovers through browsing. So if I discover a page, it will then index all the links on that page and force browse all of those. So it's kind of like a recursive fuzzer that runs repeatedly. So in this case, I'm going to run a force browse on our site, not on Cloudflare. I shouldn't do that. And hit the force browse, and it will start actually sending requests to this site, and then once it sends the first set of requests, it will start sending a subsequent set of requests. And again, if you use a list like I have in this force browse option, I've got the directory list, which is this massive OWASP list of just all common directories in most systems. It will do like 3 ... combinations and various other things. You can put that on a website, and it can take a very, very long time to run a force browse because it will recursively do it every single time. But you can run a force browse and find some interesting things. In this case, if I just sort by URL, and this is again an example of something I knew already, we found a folder helpfully named encryption keys. I move my thing there. And in encryption keys was a JWT public key and premium.key. Who knows what interesting stuff is contained in there. And that was just combining the concept of a fuzzer by running sort of a set of strings with the concept of spidering, and you get force browse, which lets you find other things on a website. So it's like a next level of scanning. The final thing, I think time-wise, I'm going to look at, before we maybe just mess around for a bit, is, again, with the HUD. The HUD is really useful because as you browse, it shows these little alerts and little pop-ups. And we can get one of those examples when we browse on this link to GitHub. If we go to GitHub, and sometimes it shows, sometimes it doesn't. So this is one of those ones that's great for a live demo. Watch the bottom corner of the screen. Maybe a little thing will pop up telling you it's just spotted a vulnerability. Didn't do it this time. But if we go back into our alerts, we will see it. It's spotted another of the OWASP top 10. It's an open redirect. An open redirect, it's seen that we've had localhost 3000, our website, redirect to some other website. And what can we do with this? We can open it in the right thing, tool for a start. We can see that when you send a redirect to GitHub, you get a response. If I just don't follow redirect there and I send it, you get a response with a location header to a different website. So it goes to Juice Shop. And this is kind of interesting if we try and exploit it. So let's try and send ourselves to this conference website, phpconference.nl. We can't do it. Unrecognized target for redirect. Someone's thought about this. They don't want us to redirect to any random website. Why would that be a bad thing? Anyone think of why an open redirect would be a bad thing?
You can put in your own...
Yeah. You can send someone a link that at the start of the link looks really safe. Amazon.com, ? Redirecting to your Amazon.com, which is a page made to look perfect like Amazon with a different domain that you're going to steal users' credentials on. Open redirects can be really, really dangerous, especially if your site is a popular website. But this person's thought about it a little bit. So ZAP spotted it. As soon as we clicked that link, ZAP highlighted that was an issue here. But we can't exploit it just yet. This person who's built the system has checked that it must say GitHub in that URL. So it must direct somewhere to GitHub, which does work if we check the GitHub. How much have they checked in this? Because checking URLs is often a bit weird. You can have things like the same URL is valid with or without a slash at the end, or with or without a question mark at the end. So you might find someone builds something, and then someone does a slash, and that one doesn't work, and someone goes, oh, okay. It doesn't matter if the URL matches. It just has to contain it, struct contains or something. So can we do something like this? Yes, we can. So all we needed to do to bypass that was to add a question mark there, and the website is fooled, and it's now going to redirect us to the PHP conference website so people can book their tickets for next year. I'm keeping dropping hints about next year because I'm hoping they invite me back. And I can go back to our website, And should have actually popped another one of the challenge things there, but it didn't for some reason. But we have managed to hack another part of the system. We have a few minutes left, so what I'm going to show you finally is probably the most sporadic and weird thing that ZAP can do, which is attack mode. Attack mode is as it's named. Attack mode essentially just goes crazy on your website. So once you go into attack mode, ZAP will just send random parameters and requests and stuff to every single URL it finds constantly until you tell it to stop. Even if you think your website is secure, I would not advise running attack mode on a production website. It will do things like create hundreds of user accounts with different random email addresses, add loads of addresses. If it's a forum, it will fill it with nonsense, forum posts or reviews. But it is still kind of fun to watch when you go into attack mode. So turn on attack mode, it tells you what it's going to do, and you turn it on, and if you just watch the requests scrolling through the back there, and how many it's doing, how many are we at so far? Number of requests, it's not even telling us. It's doing so many requests, it's not telling us how many requests it's doing. It's just going through and sending lots and lots of requests. Genuinely, these should just be updating. I don't know why they're not. But it's sending lots and lots of requests at our website, and I don't even know what it's doing. Sometimes, if you log in whilst it's in attack mode, I tried to find some sort of reproducible thing with it that attack mode would always do it. Well, there we go. It's added an address that's just blank for no obvious reason, which at the very least tells me I need to do some better form validation. If we look at the credit card section, which is here, sometimes it adds random credit cards. It's kind of fun. It's like having a hyperactive child just have access to your website. Another address has just got added there whilst we've been talking. And attack mode will just kind of keep doing that. And I think it pretty much keeps doing it forever. I don't know if there's a point where it decides it's done and it's done every possible thing it can do to your website. But again, if you're feeling really, really, truly brave, open ZAP in attack mode on your website. And that is the end of what we're going to explore with ZAP. The things we looked at, just to summarize before we finish, we looked at the basic scan, the sort of automated scan that does some spidering of your website and then finds potential vulnerabilities and alerts them for you. We looked at the proxy, where we can open up a browser, browse around, see things like the history, modify those requests. We found an alert for SQL injection, which we then used the requesting tool of ZAP to modify and inject the website. We then explored the fuzzer, where we could fuzz things like the value of form fields sent to the website or JSON payloads, or even just use a fuzzer to send lots of the same request repeatedly in a short space of time to test timing attacks. We looked at finding form parameters that aren't shown to normal users, and we looked at forced browsing as a way to combine the fuzzer and the spider to just generally crack open every single part of a website and understand it. Finally, we looked at the alerts for open redirects and the way that the alerts in the hood can help you find issues with a site. And at the end here, we're just randomly breaking the site with attack mode and hoping weird stuff happens. So that is the conclusion of the talk. I'm going to switch on to my sort of slides again, just to put something up on the screen, if that actually loads. Thank you very much. Bedankt. As mentioned, you can find me at m1k@phpc.social or add me on LinkedIn. I'll also be around the conference the rest of the day. I don't think we have time for any questions, but please come and at me with whatever you've got, and I'd love to help you out and chat more about your use case. Thank you very much.